Good morning, students. Today we are going to see a topic on queue data structure. Already we have seen what is data structure, what are the types of data structures, that is linear and non-linear data structures, what is linear, what is non-linear, all the introduction we have already seen. So today we will see one type of data structure, that is queue data structures. This is an example of linear data structure. Why we are calling it as linear data structure? Because the elements, all the elements in that queue, it is continuously stored or contiguously stored. I can access the element one after another. There is a sequential connection among the elements. There is a sequential access I can have with all the elements. So linear access I can do one after other. So that is why it is called linear data structure. Okay. So Q is a linear data structure, and what kind of process it is following, what kind of data access order it is following, under which principle it is accessed. That is, it follows first in first out manner. What is first in first out? The element which is entered first, that will be retrieved first. The element which came first, that will be deleted first. Very simple example. You're standing in a queue. Okay. So you want to get token, food token or some other token. So the person who entered or who stood first, he will get the opportunity to get the token first, right? Who is going first, they will be served first. First in, first out. Okay. Normal token system, normal queue system. In day-to-day life, everyone knows what is queue. The same concept, queue data structure. That is first come, first serve, first in, first out. The technical term we will call it as a FIFO. Okay, so this concept not only in regular queue in bank or token system, we can use this concept in real time in many applications. We will see where and all we can use this application. Okay, very simple example, technical example I will start with. Everyone knows printer, right? We will give few files for printing, correct? For example, I am giving one file for printing, and of course my friend will be giving few files for printing. So what will happen? Which file will be getting printed first? The file which is entered first, that file will be printed first. Very simple day-to-day life experience or example, right? So still more applications we will see where and all the queue data structure can be used. Okay, before that we will try to understand the structure of queue, how we can represent, technically how we can access. Okay, those concepts we'll see today. So one more point, that is, it has two pointers, front and rear. Okay, so we should have some pointers to access the data elements, correct? So how I can access the data, how I can delete the data, in which position I should insert the data, in which position I should delete the data. So for that, to maintain that positions, I should have some pointers. Okay, that is nothing but front and rear pointers. Okay, what is the use of front and rear pointers? two pointers we are having, that is front and rear pointer. What is the use of front and rear pointers? See, rear pointer I can use for insertion using rear pointer position. Okay, if I want to insert an element, so which place I can insert, that position where I can find from the rear position. And next, what is the use of front pointer? Front pointer, what for it is used? For delete an element. So which position I can delete an element? Correct, that is the element which is entered first, that should be deleted. So how I can access in that order? So how I can keep a pointer, that is which element is entered first, that thing I can get from the front pointer. So rear pointer I can use for insertion and front pointer I can use for deletion. Okay, next, everyone knows what is array and what is array representation. Here I'm going to implement queue data structure using arrays. Okay, so memory is same, everything structure, internal memory, everything is same, but we have to use that memory, we have to utilize that memory according to our application. So I want to implement queue based system, so that time I can implement like this. Or if you want to implement some other structure, so definitely there will be some other kind of data structure will be available, I can use that models or structures. So, and one more term we will see. We talked about inserting an element, deleting an element. In queue, we can call technically, we want to insert an element, that what we'll call enqueue. Technically, we will call enqueue, that is inserting an element. I'm just inserting one element into the queue. And for deletion, what we can call dequeue, deleting an element in a queue, that is why dequeue. Okay, so just this is another introduction. For example, how many elements I am having? 5 elements in this queue. We will see how I can insert, how I delete with one example. But as an introduction part, we should understand what is queue data structure. Queue is nothing but it is one kind of linear data structure. Why it is linear? I can have access to the elements one to one. There is a sequential order. Okay, that is why it is called linear access. Fine, and it follows first in first out principle. That is, the element which entered first, that element will be deleted first or retrieved first. One more simple example. For example, in dining hall, we are arranging plates. For example, 10 plates I arranged. So persons are coming in a queue. So first person will take the plate which is on top of it, right? So the element which I'm sorry. Okay, that's all. And first in, first out principle. And one more point, it have 2 pointers, that is front and rear. One is for inserting an element, and another pointer is used to delete an element. That is the position we can get from rear and front pointers. Okay, and one more we have seen, for insertion technically we'll call enqueue. For deleting an element in queue, we'll call it as a dequeue. Yeah. Okay, so several operations can be performed on queue. So what are those operations? I can just, we have seen, I can insert an element, delete an element, that is enqueue. I can do dequeue and display. I can display any element. So we'll see with one example how it is possible, right? Just we have seen how to represent a queue using array, right? Just I have shown using arrays how I can represent. right? So this is a very simple structure. Yeah, sorry for the interruption. So how to represent a queue? Okay, using arrays I have shown just before. So again we'll consider the same structure. So how many elements here I can store? Consider this is one array of elements. How many elements I can store? 1, 2, 3, 4, 5. So maximum 5 elements I can store in this array, right? So initially definitely the queue will be empty. We have to put elements one by one. Okay, so initially the queue was empty, and just we have discussed we need 2 pointers to access the queue data structure data. What are the pointers? Rear pointer and front pointer. Rear pointer is for what? Inserting an element. Front pointer is for to delete an element. So we need 2 pointers. Okay. So initially what I'm doing, I need I need front and rear pointer, and initially I'm just initializing with 0. Okay, that is both pointers are pointing in a 0th position initially, right? See, it is not that compulsory both pointer pointing 0, or I can make both pointer pointing -1 also. When inserting I can increment, or I can make both pointing as 0. That is a little difference in programmatically. That's it. Okay, concept is same. So based on this initial positions, just little program concept only will be changed. Just incrementing value only will be changed, but not the concept. So accordingly you can take any value. Both you can initialize to -1, or front as 0, rear as -1. Anything you can give. Finally you will come to know how to keep it all. By default we'll follow the same structure, so it will be easy to understand. So initially I'm just assigning both front and rear pointers 0. Fine. That is both pointers. Short form I mentioned F and R. So both pointing to the 0th position. Okay. So now we will see how I can enter value by one by one. Okay. Now I want to insert. Now I want to insert an element. Okay, so which value I want to insert? The value 11 I want to insert. Okay, so using which pointer we can do the insertion? Using which pointer we can do the insertion? That is, I can use the rear pointer for the insertion, right? I can use the rear pointer for the insertion. What I can do, initially both front and rear pointers pointing 0, and I can use the rear pointer. So I should do the changes in rear pointer. What I do, so 11 I want to insert. I'm just inserting 11 in the 0th position using rear pointer, because if I want to insert an element I can use this rear pointer position. So using rear pointer position, that is R of 0, I inserted 11. And what I can do, it means already the rear pointer is filled. One position is filled. So I want to move to the next position. So I should be ready for the next element. What I have to do while inserting an element, initially both are pointing 0 when the queue is empty. And if I want to insert an element, I want to use or, that is rear pointer, to get the position. If it is 0, I'm just putting in an element. Next, immediately I have to increment my rear point. That's all. It means what? One element is already filled. I came to another place, next place to receive the another item. Understood? Then we will see. Next, I want to again insert 22. So what will happen again? Same way. So I want to insert 22. That is using which rear pointer is pointing to the first position. So I'm inserting. Again, I am incrementing. Immediately, once you put the element, immediately you have to increment the rear pointer. It means what? That rear pointer is ready to receive the next element. And again, I want to insert 33. Already rear is pointing this position. Once I inserted this element, immediately I am incrementing. Okay. The next what will happen? Again, I want to 33 we entered, and okay, next we try to delete. Now just we'll again revise it. So what we have done, three elements we inserted. What are the elements? 11, 22, 33. Using which pointer we are inserting? Using rear pointer, right? Zeroth position. Initially both initialized to 0, and using that zeroth position or rear pointer, I'm inserting 11. Immediately I'm incrementing to next position. And one more element is coming. I'm inserting using rear pointer position. And immediately I'm incrementing by 1. So like this it goes on. So now rear pointer is pointing here. Nowhere we touch the front pointer because till now I'm doing the insertion. So front pointer is only will come into picture when we are deleting an element. Okay, so nowhere we are touching the front pointer, still it is pointing to the front pointer. And now just to recollect, which element is entered first? 11, correct? Then 22, then 23. So I can tell in this way. So front pointer is always point the element which entered first. Until unless it is removed, it will move to the next inserted element. Understood? One more time I repeat. This front pointer always point an element which is entered first. Okay. Until unless if it is removed, then it will point to the next first element. That's all. That's the logic. Okay. So we will see. I'm sorry. Okay. Now what I'm doing, I just want to delete an element. So if I want to delete an element, which pointer I can use? I want to use front pointer, because just now we have told front pointer always pointing to the element which is entered first. So using front pointer, I can delete an element which entered first, right? Okay. See, I just deleted one element which is entered first using front pointer. So again, I should be ready to the next first element, right? So immediately what I should do, immediately I should increment the front pointer. That's all. That time we are not touching rear pointer. Understood? I deleted, immediately I'm just incrementing the front pointer. Now front pointer is pointing the next first element. If it is removed, again I will increment the element. That's all. Correct. Okay. So again, I'm just deleting 22, that is using front pointer, because this is the next first element which is entered first, right? And immediately I'm just incrementing. Okay. So now front pointer is pointing the position 2, index 2, or pointer is pointing to the index 3. So when we are deleting element, nowhere we are touching the rear pointer. That is still same, because this won't come into the picture because we are doing the deletion using front pointer. That's it. And next we'll see. Next again I want to insert an element. If I want to insert element, where I have to do? Using rear pointer. I'm just inserting 44. Immediately I am inserting. And next again I want to insert 55 also. I'm inserting. I'm trying to increment. Okay. Or point I'm trying to increment. So 4 plus 1, rear plus 1, 4 plus 1, it will become 5. It will become 5. What will happen? So I'm just checking the maximum number of values. What is the maximum number of values? I'm just checking. So that we have to store in program, that is the maximum how much my queue can hold. For example, 3, 4, 5. So almost my queue can hold 5 elements. Okay, and rear point is starting from 0. So obviously when rear is reaching 4, that time itself my queue is filled. So when I'm trying to increment, rear is become 5. It means it is greater than or equal to our maximum queue size. Okay, that time we can come to an conclusion that queue is full. That is, we reached the last position. We will see. When I'm trying to insert 66 after this, what will happen? What will happen? Because it it is beyond the maximum size. Correct. It is crossing the maximum size. So definitely I cannot insert. So I have to mention that my queue is filled. So technically, which term we can use if queue is filled? Overflow. Okay, what term we will use? Overflow. That is when my queue is filled. When my queue is filled, it is called as overflow. See, already my rear point is crossed the limit. Correct. That is crossed the maximum size. Okay. So that time I cannot insert any more elements here. So obviously my queue is filled. So technically I can call overflow. Right. And next we'll see. Okay. Till now what we have seen, that's it. And one more version is there, what is circular queue, that we will see again. Now don't want to confuse it. Okay, just we'll see the source code for queue operation, right? The major functions what and all we have seen: how to insert an element, how to delete an element, and how to display. So just we'll frame an algorithm ourselves. If we want to insert an element, what I have to do? Before that, I should initialize both front and rear pointer to 0 or both to -1. That again it depends on you. You can decide. Just increment decrement only will vary. That's all. And here what we are following, just both I mean slice to 0. It is not a thumb rule that you have to initialize to 0. That is why I'm just insisting. So both I'm initializing to 0 as per our program. Okay. If you want to insert which pointer, I have to think of a rear pointer. So using rear pointer, I can insert an element one by one. If it crosses the maximum range of my queue, then I can tell, oh my god, the queue is already filled. So print overflow, right? And deleting. If I want to delete, what should I think of? Front pointer. Using front pointer, I can delete an element. And after deleting, I can increment one by one, because it always point the elements which is entered first. If I deleted the first element, then obviously it will start pointing the next first element. That's it. Okay. And if no more elements are there, it will print underflow. That is, if queue is empty, it will tell it is underflow. That's it. Okay. Just we'll see the methods, that is program, how to insert. So whatever we discussed orally, that thing will, all the thing will be written in a statement, all the program statements. You just will see what we have to check initially, whether my queue is full or not. That time we have to check whether is there elements are there to insert or not. Correct. If not, I can tell queue is full or overflow. So how I can check my rear pointer whether it is reached to maximum? Correct. So we'll have one example, right, like this. Okay, so we have both F and R, right? Both F and R pointing to 0. if I have all the elements filled, okay, my rear pointer will be in this position. Obviously, rear is equal to max, so Q is full. Else, what I can do, I have to read the data first. Okay, I have to read the data. In which position I have to put the data? If it is insertion, means I can access using rear pointer. That's it. And immediately I can insert the immediately I can insert the rear pointer. Once I entered an element, immediately I can increment the rear pointer. See, I read in one element and I put that element using rear pointer. Immediately I inserted this rear pointer. For example, both in 0 position initially, my maximum size is 4. Okay, for example, max equal to 4. Okay. Now again I'm just calling insertion. So what will happen? I'm just checking whether r is equal to max. R is 1. It is not equal to max. That is, it is not equal to 4. So what I'm doing? I'm just again inserting one element. So what will happen after inserting an element? Immediately I have to increment the rear pointer because I should move to the next free space, right? And again I want to insert an element. That is, once I inserted element, immediately I want to move the rear pointer, right? I'm just moving the rear pointer here, and I'm putting the value 8. Correct. And same way I just shown the delete also. Okay, now what I'm thinking, I'm just trying to delete an element. So if I want to delete an element, before that I should check whether it is empty or not. Okay, when I can check empty, okay, when the queue will be empty, I will explain once again. Initially, when the queue is empty, what is the value of front and rear pointer? Initially, when the f equal to or equal to 0 initial setup, right? So both are equal to 0. Correct. That time obviously the queue is empty, and one more time is also this will become empty. I will explain. So we have inserted till 8, right? Now I want to delete one element. What will happen? I want to delete element. I can delete the element using front pointer. I'm just i'm just deleting i'm just deleting the number 5, right, using front pointer. As soon as I and deleted using front pointer, obviously my front pointer should point to the next first element, correct? Because front pointers always point to the element which entered first, right? And again I want to delete an element. What I will do, using front pointer I will delete element. Using front pointer I'm just deleting element. As soon as I'm just deleting, I should increment my front pointer, right? Because always it will point the element which is entered first. Correct. Now I want to insert an element. Now again I want to insert the element. So if you want to insert an element, because when I inserted 8, obviously I should increment it to or here, right? Now again I want to insert an element. I'm just checking whenever I want to insert, I'm just checking whether or equal to max. Now actually or 3 plus 1, now it will become 4. So that is or equal to max. So it means q is full, that is rear pointer reached to the last position. Okay, and obviously that is q is full. This condition we have seen, and this condition one more time it will happen. We will see how come. Again I want to delete. Okay, I'm just deleting using front pointer. I'm just deleting, and as soon as I deleted one element, I have to increment my front pointer, and again I'm just deleting. Okay, that is using front pointer. As soon as I deleted, I should increment my front pointer. So both my front and rear pointer pointing to 4. Correct. That is when both values are equal. That time Q is empty. Right. That is why the rule have come if both rear and front pointing to the same position. And one more example also I can tell. See, I'm having 10, I'm having 12, I'm having 13. Okay, so obviously where my rear value will be, because once I enter the element, immediately I will increment my rear pointer. Where will be the front pointer? Obviously it will always sit with the element which entered first. So my front pointer always will be pointing the element which is entered first. So front pointing to the 10. Now I want to delete one element. Okay, so I'm just deleting. Correct, I'm just deleting. So front pointer will move to the next position. Again I want to delete. Again it will move to the next position. After deleting, my front pointer will come here. Now again I want to delete. This time I will check whether both are equal. Yes, both are equal. So whenever both front and rear pointers are pointing to the same location, obviously it means that there will be no element, that is Q is empty. That's all. Right, that's all the possibilities we have seen. And if I want to display elements, so one more important operation in Q, how I can display elements. So how I can display elements? So again one more example I will show. Okay, think that here one person is here to give the token. Okay, first person waiting here, second person waiting here, third person waiting here, fourth person is waiting here to receive the token. Okay, so we know very well, if first person gone and got ticket, then second person will come, then third person, then fourth person, right? Okay, now what happened, just imagine I want to check how many persons are there, in what order I want to give the token. So you just tell me where is the front pointer. So here will be my friend, and we'll make it simple. And where will be my rear pointer? My rear pointer will be here. Correct, as per our logic. That is, I entered till this, so obviously my rear pointer will be here, and one element have gone, and again I should point to the next first element. So now I want to display who are all waiting in the order. So which, who should come first? Second person and then third person, right? This should be the flow. Correct. So in that order, if I want to print, that is, I should start from front pointer and I should end before the rear pointer. So these are the elements I should retrieve. Correct. So that is why in program you're starting from front and I'm just checking less than rear. Okay, I'm just starting from front pointer and it should be less than rear. Till that all the elements I'm just retrieving. Understood? And one more simple example I will try to. First person, all are here. Okay, so obviously my front pointer will be here because who entered first, and rear pointer will be pointing out because already all four elements fill. Zeroth position, first position, second position, third position. Now I want to display in the order. I want to display all the elements in the order. So where I should start with? I should start with front and till the rear pointer. That is why I equal to front, I less than rear, one by one I'm printing. So 1 will be printed, 2 will be printed, 3, next 4, right? That's it. and you know very well how to put the switch cases and all, so you can add. Yeah, in initially itself I told there are many applications of queues. So what are those applications? Schedule the jobs to be processed by CPU, right? You might have heard job scheduling algorithms, first come first serve kind of things. That is the process which is entered first in a job queue, that job will be given with CPU access. Okay, the job which is entered first, that will be get access to the CPU first. That's all, right? And also I have explained printing jobs in a printer. So files which is entered first, that will be printed first. And one more important, breadth first search will use queue data structure. So we'll see in forthcoming sessions what is breadth first search, depth first search, how we can use queue or stack data structures to access elements. We'll see in a next session. So this is all about a normal queue introduction, or we'll say linear queue or normal queue. Okay, I'll just once again will brief it. So Q is one of the linear data structure, right? Where we can insert an element at one end and deletion can happen at another end. So to maintain these both ends, we used two pointers. One is front pointer, another one is rear pointer. Rear pointer is to inserting an element. Front pointer is to delete an element. Okay, and what term we can call, what order it is accessing the data. So it is accessing the data in order of FIFO, first in first out. The element which entered first will be retrieved first. The element which is entered first will be retrieved or will be deleted first. That's it, right? And two important technical terms, NQ and DQ. Because if you want to insert an element, that process we can call NQ, that is inserting an element. If you want to delete an element, that we'll call DQ. So by seeing all the examples, now you'll know insertion happen at the end of the queue, that is why NQ, correct? So deletion, where it's happening at the start of the queue, right? And how to represent the queue? Okay, so initially the queue is empty and both my front and rear pointer pointing to 0. Again, I'm just reminding, it is not always both pointers should point to 0. Okay, you can make it as -1 also, but programmatically you have to do the necessary changes, right? And whenever I'm inserting element into the queue, I have to use rear pointer and immediately I have to do the increment of rear pointer, right? And in the same way, whenever I want to delete an element, I should use front pointer and immediately I should increment the front pointer, because my rear pointer should always be ready to receive an element and my front pointer should always point the element which is entered first, until unless if it is deleted, and again it should point to the next first element. That's it. And we have to check for the few conditions. What are the conditions? Whether both my front and rear pointer is pointing to same position, so that time it is empty. Whether my rear pointers reach the maximum position, that time it means queue is full. Okay, so these are the common conditions you should know before implementing queue. So that's all. Insertion, deletion, display. Insertion, what you have to check? You have to check for overflow, whether there is a space to insert or not. Deletion, what you should check for? Underflow. There should be at least one element before you delete. Okay, so insertion, what is the condition? First you check for overflow. How you will check? If my rear pointer point reach the maximum, then it is overflow. That condition you have to check. Else You can read an element, you can put the element using rear pointer because insertion, then immediately you can insert the rear pointer because rear pointer always it should be ready to receive a new element. And delete, what I can do with delete, so before deleting you should check the one condition. What condition you have to check? You have to check for the underflow, whether at least there is one element or not to delete. So how I can check one condition? If your rear and front pointer pointing same value, that time obviously your queue is empty. It can be the initial stage or after inserting deleting few elements also. If both are pointing to the same value index, then obviously the queue is empty. Else, yes, you can retrieve the data using which index? Using the front pointer. That's it. And immediately you can increment your front pointer. For display is nothing but from the front pointer because first come first serve. So first come who is pointing? Obviously front pointer. So from the front pointer till the rear, I am just printing all the elements in the order. So what are the applications we have seen? One is job scheduling, it is used, and printer to print the jobs in order it is used. And then in breadth first search we can use queue data structure. In detail we'll see in future class. That's it. This is all about linear queue. So next session we will see what is the disadvantage of this linear queue structure, how to overcome that. Thank you.